Hello, beautiful people, and welcome. In this video, we are talking about arithmetic sequences. Now, personally, I think it's super duper funny, with the English language. So when you are writing arithmetic, you're actually writing it as if you're writing arithmetic, but it's arithmetic. It's weird. Anyway, so we are talking about arithmetic sequences. And before I get into the content, I will do my disclaimer. I am human. If I make a mistake, that is okay. Let me know where the mistake occurs so that way I may learn from it. Alrighty, let's jump in. So a sequence, when we're talking about any sort of sequence, it's an ordered list of numbers. Now, what does that mean? Now, it doesn't have to have, a sequence doesn't have to have any sort of pattern, anything, okay? It's just a list of numbers. So, for example, you can have 1, 2, 3, 4, etc. That's a list of numbers. Another sequence could be, 2, 5, 7, 8, 9. That is also a list of numbers. It is ordered with commas and everything. It is a list of numbers. Now, a term is each individual number in the sequence. So for example, 1 here is a term, 2 is a term, 3 is a term, 4 is a term. Each individual number is a term. Now, when we're talking specifically about, let me see, I'll just tell you what this is. We are going to talk about series in another video. So a series is you're taking all of the individual terms of the sequence and you're adding it up. So for example, for a series, you would do 1 plus 2 plus 3 plus 4, etc. So you would take all of your terms in the sequence and you would add them together in order to get a sum. We'll talk about series in another video. All right. Now, when we're talking about arithmetic sequences, now arithmetic, that's where the pattern comes into play. Not only do you have a list of numbers, you have a list of numbers in a particular order, and it has to be in this specific order. So an arithmetic sequence contains a pattern where a fixed amount is added from the one term to the next, which is the common difference after the first term. Let me explain that a little bit. So let's define common difference here. I didn't leave too much space. I'm going to try to put that in there. So a common difference is the pattern. You're going to take your right term and you're going to subtract your left term. And you're going to do that for all terms. So 2 minus 1, 3 minus 2, 4 minus 3. I'm looking at this particular one. If all of those differences are common, then you have a common difference. Now, if you don't have a common difference, if the difference are different between the right and the left term, then your sequence is not arithmetic and you may not proceed with the rest of what we're going to be doing today. So let's go back here with our two examples. So let's start with this first one here. So to find our common difference, to see if our sequence is arithmetic, we're going to take 2 minus 1, see what that is. Then we're going to do 3 minus 2, see what that is. Didn't mean to move that. And we're going to do 4 minus 3 and see what that is. So 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. So our first example of 1, 2, 3, 4, that is a common difference of 1, meaning that our sequence is arithmetic. Now let's do the other one. 5 minus 2 is equal to something. 7 minus 5 is equal to something. Now, you can continue with all of them, but once you see that they are not the same, you can stop and say, hey, the sequence is not arithmetic. So 5 minus 2 is 3. 7 minus 5, 5, 6, 7, that is 2. Notice that these two are different. So that means not arithmetic. So the first one is arithmetic, the second one is not. All right, let's go ahead and talk about formulas. Now, if you do have a common difference and your sequence is arithmetic, you're going to have a few different formulas that you need to know. So two of these formulas are going to be more often used than the other ones, but you still need to be aware of all of them. All right, so the very first one we're going to do what's called the explicit rule. Now, this explicit rule is going to be starting at 0. Now, what n equals 0, what that means is the position number your first term is. And again, we'll do a quick example. So the explicit rule starting at 0, and I'm going to give you two forms. That's why I created two boxes here. So a sub n is equal to a sub 0 or a naught plus d times n for n greater or equal to 0. Now, just to let you know, this n right here represents the position number. So for example, let's go back to our example here. This number here, this 1, is in the first position. This number is in the second position. This number is in the third position. So it doesn't matter what the term is, we're talking about the position number of the term. So if you were using this explicit rule, you would have the position of your first number being 0. The number is not 0. The position it is in is 0. Now, a different way that you can write this is using subnotation, meaning you have little n's at the bottom. So like a sub 1, a sub 2. You can also use this notation of f of. So for example, f of n is equal to a plus d times n for n greater or equal to 0. Now let's do an explicit rule starting at 1. Alrighty, let's go ahead and I'm going to do that. A sub n is equal to a sub 1 plus n minus 1 times d. Make sure that you are going to be distributing that d inside the parentheses. And that's going to be for n greater or equal to 1. That means the first number that you see is in the first position. F of n is equal to f of 1 plus n minus 1 times d for n greater or equal to 1. Again, make sure that you are distributing the letter d or the common difference, not just the letter, it's common difference. All right, so explicit rules we're going to be loving. Explicit rules we're going to be loving for the majority of our time in class. We're going to be loving the ones starting at 1. Now, you will have explicit rules starting at 0, but they're just less often. Right, now we have recursive rules. Now, recursive rules, we kind of don't like recursive rules. The recursive rule depends on the previous number that you know. So what that means is, let me write this down here real quick. And then we're going to have a recursive rule starting at 1. Okay, so what the recursive rule is, a sub n is equal to a sub n minus 1 plus d when a sub naught or a sub 0 is equal to something for n greater or equal to 1. This is just fancy notation. You have a term, a sub n. My a should be a little bit bigger than my n. So a sub n is equal to a sub n minus 1. So you have a term. So whatever this term is in, the position number is n. We need the previous term in order to know what our term is. For example, If I want to find out what the number is in the fifth position, I want to know what a sub 5 is. I want to know what the term in the fifth position is. If I want to know what the term in the fifth position is, I need to know what the term is in the fourth position. And if I need to know what the term is in the fourth position, I need to know what the term is in the third position. And if I need to know the position in the third position, I need to know what the term is in the second position. Do you kind of see the pattern? You cannot find what number is in the fifth position unless you know what's in the fourth, the third, the second, the first position. That's where it gets a little bit weird with recursive. You still need to know what it is, but we're not going to use it that often. We like explicit rule. Explicit rule makes us happy. Okay, so f of n is equal to f of n minus 1 plus d for f of 0. Oh, one thing I didn't mention is you do need to tell the reader what your f of 0 is, or in the next equation, what f of 1 is. The reason we need to start is because we always build on the previous number. If we don't have the first number, then we don't know what to build off of. So you need to tell the reader always what comes first. Here's a sub n for the other equation, a sub n minus 1 plus d. And again, same thing for a sub 1 is equal to something for n greater or equal to 2. Now this greater or equal to 1 is different here, greater or equal to 2. Because we're starting at 1, we already know what the first position is. So we need to start with the second position because we're telling the reader what's in the first position. So f of n is equal to f of n minus 1 plus d when f of 1 is equal to something for n greater or equal to 2. Okay, so these are the formulas that you're going to need. Again, we're going to most often than not use the explicit rule starting at 1. However, you do need to identify all of them. So if I give you something in this formula, in any of this formula, you need to tell me what the common difference is. You need to tell me what a sub 1 is. You need to tell me what a sub naught is if that is the equation given. Alrighty, beautiful people, I'm going to wrap up this video. Make sure that you write the equations down. And then in the next video, we're going to work on examples. Bye.